Hey everyone, this is Slauson. So we are again in chapter 2 packet, which is yellow, and I am on page 6. Now there is one Algebra 1 class that did get some of these notes, not all of them. So if you are that class, if you are that person, just fast forward the video for this round and what's the word I'm trying to say? and get to where you need to be. The rest of you do not fast forward, usually don't have that option, but you will have that option in this video to move ahead. But the rest of you, please don't fast forward because this is pretty important stuff that really goes throughout the whole rest of the year. So we've been talking about function and function notation. And so today what we're going to talk about is how do you evaluate or how do you solve a function. And so we've already done these things. They're just going to look a little different. So the main thing to realize is that, kind of recapping our back notes, that y is going to be f of x. They are the same thing. And when you see a number in the parentheses like this is me telling you what x is. All right? So in something like this, I'm asking you, all right, if x is 3, I want to know what y is. But instead of y, we're going to say, well, what's f of x? That's our big question to answer. And if you have it looking like this, so the number's not in the parentheses on the other side, remember this is just another way to write a function. H of t is how you say it. That's the same as y is 54, and then you substitute your y value in. Okay? All right, so first we're going to evaluate. Remember, evaluating is where you do follow PEMDAS. And I've got 3 problems here, and I'll be putting those 3 problems in their particular function. So we have f of x, g of m, and h of t. And with this one, again, I already told you if this means if x is 3, what's y or what's f of x. So we're going to be using this function. And I'm just going to say, all right, I'm trying to figure out what f of x is. And where there is that x, I'll be putting 3 in. And again, if you like to draw that wall like I do, I'm trying to figure out, PEMDAS normal, PEMDAS backwards. When it's just all numbers, it's just regular PEMDAS. And I don't have any parentheses or exponents from PEMDAS, so I'll just do my multiplying. I want to multiply, I get negative 12. Then I want to take away 3. And then when I'm done, we get negative 15. So in the past, we would say y equals negative 15. Here, we can kind of just replace y with f of x. But a better way to write this answer would be, all right, my function, when x is 3, gives me an answer of negative 15. So this is the best way to write the answer. This is the second best way to write the answer. Don't just write negative 15 and we want to try to get away from y equals now. All right, in this one, we're using this function. So they're not using x and y. X is now m. And I'm saying, all right, if m is negative 3, I want to know what g is worth. And g is taking the place of y. So I'm going to go to my function, and I'm going to replace that m with negative 3. So what is g of m if I take negative 3, square it, and then add 4? So following the order of operations, there are parentheses, but these parentheses are just holding the negative number, and I'll explain why I put those in parentheses in a moment. But otherwise, the exponent means negative 3 squared, which is negative 3 times negative 3, and that's 9. And after I add 4, I get 13. So again, good way to write the answer. But the better way is my function, when m is negative 3, gives me an answer of 13. So what I want to do is just show you one piece on the graphing calculator. And I think I'm going to have to make this a little brighter. Okay. So if I take negative 3 squared and add 4 on this graphing calculator, and this would happen on most calculators if you did it this way, you're going to see that we don't get the 13 that I already told you was the answer. And that's because when the calculator sees this, it doesn't see a negative. It actually sees the opposite. So it wants me to take the opposite of 3 squared. Well, if 3 squared is 9, then the opposite is negative 9. So it sees this. So what I need to do is put that negative number in parentheses so it doesn't see it as the opposite of 3, but it sees it as negative 3. All right, and then I'm going to enter, and then you get your 13. So a good idea is anytime you take a number to any exponent, wrap that number in parentheses, and then the exponent will go on the outside. All right, last one. We're going to use this function, h of 2. And so again, this is saying t is 2. And if t is 2, I want to know what h is worth. So I'm going to go to my function, and I'm going to go 2. They have parentheses. Again, that parentheses is just holding the number in. You really don't need it. And then instead of t, I'll put to the second power. So here's that wall. I didn't draw the wall here. So PEMDAS, there are parentheses, but again, that I don't need those parentheses. It's just holding it in there. Because again, anytime you take something to a power, it's really a good idea to wrap it into a fraction. So your calculator, if you do use your calculator, knows what you want. After that, I do exponents. So that's 3 squared, which is 9. And then I'll take the 9 times 2, finishing this up, and I get 18. So again, good way to write the answer is this. The best way, my function h, when t is 2, gives me an answer of 18. All right, so this was all evaluating. Again, when you evaluate, the number is in the parentheses. All right, when you evaluate, the number is in the parentheses. All right, going to number 9. 10 and 11. So now the number is outside of the parentheses. And again, that's the same as me giving you y. So if this were a regular problem back in chapter 1, I would say, all right, given y is 54, what's x? But now we're given h, or h of t is 54. So I'm going to go to this function. We're still working with these same ones up here. And I'm going to go to where h of t is, right here, and I'm going to replace this with that 54, because down below it says h of t. Well, it is 54, and I just want to find the regular t. So it'll be 54 equals, and I'm going to drop those parentheses on this one. Okay, and now I'm going to solve. And my first step to solve, this is PEMDAS backwards. You're not going to see that prep work. There are no parentheses. I can't distribute. There's no combining like terms. You will not make this 6, because then what you're doing is you're saying that I should multiply before there's an exponent, and that's not how this problem would work. What I would normally do is 3 to some power, get that number, then I would take it times 2 to get to 54. But if you make this 6, then you're changing how the problem is set up. So there's no moving the variable to one side, so I'm just going to work to get that t alone. So first I'm going to move this 2, that's multiplying to 3. I'm going to divide by 2, and now I get 3 to a power. So remember, an exponent tells you how many times you're multiplying something. So just as a reminder, like 5 to the 4th power means I should be multiplying 5 4 times. Okay? So the big number is the number that's multiplying over and over. The little number, the exponent, tells you how many times to multiply that number. So what I want to know is how many times do I need to multiply 3 until I get to 27? And as it turns out, it takes 1, 2, and 3, because 3 times 3 is 9, 9 times 3 is 27. So here my answer is 3. And it is fine to write the answer like this, but if we kind of want to stick to this format, I would say, all right, my function, when t is 3, this t right here, gives me an overall answer of 54, going back to the top problem. Okay? For this, this is kind of new, so if you just want to write it like this, that would be okay here. All right, next one, g of m. So I'm going to go to this function. And again, I'm telling you that g of m is 20. So I'm going to go up here to where g of m is and put the 20 in. So it's going to be 20 equals, you can't see that, m squared plus 4. Draw my wall, and let's talk about the prep work. No parentheses to distribute, no combining of like terms, no getting the variable on one side. We just got to get m alone. So first you move your addition subtraction, and that's 16 here, and m squared here. And now, to get rid of the squared, there is an option, and we can start talking about this option. Most opposites, adding versus subtracting, multiplying versus dividing, are next to each other on the calculator. See that? So on your calculator, somewhere, depending on your calculator, you're going to see a squared button. And its opposite is right above. It is a square root. So that is one way to do this. To undo the square, you just square root. And this check mark cancels out that little 2. And then I take the square root of 16. And if you do that on your calculator, I'll just hit the second and then this x squared button. That pops up and I get a 16 and it's going to give me 4. So here's the catch. There's actually another answer because there's another number that I can square to get to 16. And that's what one of the questions on the week 2 quiz was, with Becky and Margot says the answer is 3 and Becky says it's 3 and negative 3. Well, that's what's happening here. It's not just 4, but it's also negative 4. And the calculator won't tell you that because technically the square root of 16 is 4. But when you solve, you have to think of all the possibilities of what might work. And 4 times 4, or 4 squared, is 16. And negative 4 squared, or negative 4 times negative 4, is 16. So even though the calculator will only tell you one answer, you got to remember sometimes there might be 2. All right, last one. We're going to do g of m again. And so I'm going to take the 13 and put it into here. So it'll be 13 equals m squared plus 4. I'm going to draw my wall, and I'll do the same steps because it's the same problem. So subtract 4, subtract 4. Now I get 9 with m squared. And so now to undo the square, I can square root. And if you take the square root of 9, again, you can use your calculator, you'll see it's 3. But you have to remember that not only is 3 squared, 3 times 3, 9, but